Now we're going to dive into more detail on one of the features that makes Raspberry Pi very interesting and which in fact allows it to interact with the physical world. That is the topic of GPIO pins. GPIO, or General Purpose Input-Output pins, can be used as a mechanism for the Pi to interact with the real world in amazing ways. In one mode of operation, these pins can be used as inputs to take readings and can be connected to switches, sensors, or other devices or computers. The GPIO pins can be used as outputs to turn on an LED, for example, or send control signals to motors, servos, or any other device. The ability of a Raspberry Pi to connect to a network means that any devices that are attached to it can be controlled from anywhere, and those devices can send data back to the Pi. Connectivity and control of physical devices over the internet is a powerful and exciting opportunity, and the Raspberry Pi is ideal for this. This connectivity of things and devices is often referred to as the Internet of Things, and the Raspberry Pi platform is excellent for prototyping Internet of Things projects. Now let's take a closer look at the Gpio pin layout. Here we will examine the layout for the Raspberry Pi 3. There are 40 pins altogether. Pin 1 on the Raspberry Pi board is referenced by pin 1 on the diagram. Then we have pin 2, pin 3, 4, and so on. Why you see two different numbers listed is because when you are interacting with GPIO pins programmatically in code, as is the case with Python, you can use the pin numbers, which is referred to as board mode, or you can use the Broadcom GPIO numbers, which is BCM mode. We will see this in action later on when we dive into some code with our circuit examples. GPIO typically operates at 3.3 volts for all inputs and outputs. At the top of the connector, however, there are 3.3 volt and 5 volt power supplies. One 3.3 volt pin on the left and two 5 volt DC power pins to the right. In addition to the one 3.3 volt pin at the top, there's also another 3.3 volt pin lower down. As you'll notice, there are also several ground pins. These are shown in black on the pin layout diagram. Any pin that has a number next to it can act as a GPIO pin. Those, however, that have another name after them also serve another special purpose. These pins can be controlled programmatically using a programming language such as Python to take readings and measurements or send outputs to connected peripherals. We will actually see this in action a little later on. For example, physical pins 3 and 5, or GPIO 2 and 3, also serve the dual purpose of serial data and serial clock lines for the I2C interface. Also, physical pins 19, 21, and 23, or GPIO 10, GPIO 9, and GPIO 11, are the MOSI, or Master Out Slave In, MISO, Master In Slave Out, and the serial clock lines for the SPI interface. Although GPIO pins can be used as digital input or outputs, one thing to note is that unlike Arduino, the Raspberry Pi does not have any analog pins. In order to process analog readings, an external analog to digital converter must be used. Now, let me give you some tips for reducing the risk of damage to your Raspberry Pi, especially when working with GPIO pins. It should be noted that unlike Arduino, the Raspberry Pi does not have a lot of built-in fuse protection and is very fragile when it comes to working with external electronics. A good rule of thumb is to make sure your Pi is powered off and not plugged in when wiring up circuits, and double check your wiring before you boot up. Also, do not put more than 3.3 volts on any GPIO pin. This could potentially damage the pins and shorten the lifespan of your Raspberry Pi. It's also good practice to not draw more than 3 milliamps of current per output. More current can be drawn, but again, this could shorten the lifespan of your Raspberry Pi. A very important point is to not poke at the GPIO connector and with a screwdriver or metal object when the Pi is powered on. Believe me, I have done this myself by mistake, and yes, it actually ruined the Bluetooth and Wi-Fi capabilities on my Raspberry Pi 3. So again, you have to be very careful and not short any of the GPIO pin connections when the Pi is powered on. Also, you should not power the Pi with more than 5 volts. Sometimes the AC adapters that are sold to power the Raspberry Pis may be of a cheap quality or may be defective, and if you supply the Pi with more than 5 volts, or if the signal is not regulated, you can in fact damage your Raspberry Pi. The best advice I have here is ensure that you have a reliable power supply for your Raspberry Pi and that it gives a clean, steady signal of 5 volts. Those power supplies that come bundled with Raspberry Pi kits are typically good ones that you can use, but if you are buying a power supply separately, just ensure that you check the ratings and reviews on it and ensure that it is suited for the Raspberry Pi. Also, in working with the 3.3 volt supply pins, you should not draw more than a total of 50 milliamps from these pins. This excessive current draw, again, could permanently damage your Raspberry Pi. And also, when working with the 5 volt supply pins, you should not draw more than a total of 250 milliamps. Again, drawing a large amount of current could damage your Raspberry Pi, so be careful in working with those pins. So now that we have an introduction into GPIO pins and what they are and how they allow us to interact with the physical and real world with our Raspberry Pi, it's time to get a little more hands-on and see GPIO pins in action.